Another day, another story. A lever is a simple machine that consists of a rigid bar that is free to pivot about a fixed point called the fulcrum. The fulcrum is the point where the lever is supported, and it is the point about which the lever rotates. The other 2 points on the lever are the load and the effort. The load is the object that is being moved by the lever, and the effort is the force that is applied to the lever. There are 3 types of levers. 1. First-class lever. In a first-class lever, the fulcrum is located between the load and the effort. 1. This type of lever is often used to amplify force. 1. For example, a seesaw is a first-class lever. 1. When you push down on one end of the seesaw, the load on the other end is lifted up. Second-class lever. In a second-class lever, the load is located between the fulcrum and the effort. This type of lever is often used to amplify distance. For example, a wheelbarrow is a second-class lever. When you push down on the handle of the wheelbarrow, the load in the bucket is lifted up. Third-class lever. In a third-class lever, the effort is located between the fulcrum and the load. This type of lever is often used to amplify speed. For example, tweezers. When you use tweezers to pick up something small, the fulcrum is located at the pivot point where the 2 tips meet, the effort is applied at the ends of the handles, and the load is the object that you are picking up. The mechanical advantage, MA, of a lever is the ratio of the force exerted on the lever to the load being moved. The MA of a lever can be calculated using the following formula. MA equals effort arm, load arm. Where 1. F arm is the distance between the fulcrum and the point where the effort is applied. 2. Load arm is the distance between the fulcrum and the point where the load is applied. The MA of a lever can be greater than 1, which means that the lever can amplify force. However, the MA of a lever can never be less than 1, which means that the lever can never magnify distance. Levers are used in many different machines and tools. Some common examples of levers include 1. Seesaw. 2. Wheelbarrow. 3. Nutcracker. 4. Pliers. 5. Scissors. 6. Tweezers. 7. Rake. 8. Shovel. 9. Fishing rod. 10. Broom. Levers are a very important type of simple machine, and they are used in many different applications. They are a great way to amplify force, distance, or speed. The principle of a lever states that the product of the load and the load arm is always equal to the product of the effort and the effort arm. This means that if you increase the effort arm, you can decrease the amount of force you need to apply, and vice versa. The principle of the lever can be expressed mathematically as follows. Load times load arm equals effort times effort arm. Where 1. Load is the force applied to the load arm. 2. Load arm is the distance between the fulcrum and the load. 3. Effort is the force applied to the effort arm. 4. Effort arm is the distance between the fulcrum and the effort. The principle of the lever can be used to explain how levers work. When a force is applied to the effort arm, it creates a torque, which is a force that tends to rotate an object around an axis. The torque created by the effort arm is equal to the force applied multiplied by the distance from the fulcrum to the effort. The load arm also creates a torque, but in the opposite direction. The torque created by the load arm is equal to the weight of the load multiplied by the distance from the fulcrum to the load. When the 2 torques are equal, the lever is in equilibrium and the load does not move. However, if the torque created by the effort arm is greater than the torque created by the load arm, the lever will move in the direction of the effort. The principle of the lever can be used to amplify force, distance, or speed. To amplify force, the effort arm should be longer than the load arm. This will increase the torque created by the effort arm, allowing you to lift a heavier load. To amplify distance, the load arm should be longer than the effort arm. This will increase the distance that the load moves, but it will also require you to apply more force. To amplify speed, the effort should be applied closer to the fulcrum than the load. This will increase the speed that the load moves, but it will also require you to apply more force. The principle of the lever is a very important concept in physics and engineering. It is used in many different machines and tools, such as seesaw, wheelbarrow, nutcracker, scissors, and tweezers. Solution. The mechanical advantage, MA, of the lever is MA equals effort arm, load arm, equals 3 divided by 6 equals 0.5. This means that the effort required to lift the load is 400 divided by 0.5 equals 800 N. Therefore, the effort required to lift the load is 800 N. Here is another example. Solution. The load arm of the crowbar is 10 cm equals 0.1 meters. The effort arm of the crowbar is 2 meters. 0.1 meters equals 1.9 meters. The mechanical advantage, MA, of the crowbar is MA equals effort arm, load arm, equals 1.9 divided by 0.1 equals 19. This means that the least force which must be applied at the other end of the crowbar is 1000 divided by 19 equals 52.6 N. Therefore, the least force which must be applied at the other end of the crowbar is 52.6 N. Thanks for watching.